4 automotive manufacturers announced production suspensions within 72 hours. The stated reason in each case was identical: inability to secure sufficient silver supply at prices compatible with production economics. This is not a story about electric vehicles. This is not a story about automotive supply chains. This is not even primarily a story about silver. This is a story about what happens when a monetary metal, a metal that has served as money for 5,000 years, collides with industrial demand that treats it as merely another input. The collision reveals something that commodity analysis cannot capture. Silver occupies a unique position in the periodic table of elements. It possesses the highest electrical conductivity of any metal. It possesses the highest thermal conductivity. It possesses antimicrobial properties that no synthetic material can replicate. These properties made silver essential to the electrical age. They make it indispensable to the digital age. They make it irreplaceable in the energy transition. But silver also carries 5 millennia of monetary history. It has been money longer than any currency that exists today. It has outlasted every empire, every central bank, every fiat experiment in recorded history. When industrial demand competes with monetary demand for a metal that cannot be printed, synthesized, or substituted, the competition does not resolve through normal market mechanisms. It resolves through rationing, through allocation, through the revelation that price signals alone cannot balance supply and demand when demand is inelastic and supply is geologically constrained. 4 production halts in 72 hours are not a market event. They are a system event, and system events require system-level analysis. The question being asked across financial media is the wrong question. The question being asked is, how high will silver go? This question assumes that price movement is the signal, that the story is about numbers on a screen, that understanding means predicting where the number goes next. The correct question is different. The correct question is, what does it mean when industrial civilization cannot secure a metal that monetary history suggests should be held, not consumed? This question reframes the entire situation. Silver's industrial consumption has accelerated precisely as its monetary function has been systematically suppressed. For decades, silver was treated as an industrial commodity, useful but not special. Its price was managed, its monetary status was denied, its above-ground stockpiles were drawn down to feed industrial consumption. This arrangement worked as long as stockpiles existed to draw from. The arrangement worked as long as mining supply grew faster than industrial demand. The arrangement worked as long as investment demand remained dormant, allowing industrial users to access metal without competition from those seeking monetary insurance. Each of these conditions has reversed. Stockpiles that accumulated over centuries have been depleted. Annual mining production has plateaued while industrial demand accelerates. Investment demand has awakened as confidence in paper systems erodes. The production halts are not surprising when viewed through this lens. They are inevitable. They are the mathematical consequence of trends that have been visible for years to those willing to see them. The question is not how high the price goes. The question is what kind of system emerges when a monetary metal is required for industrial survival and available supply cannot satisfy both functions. The history of industrial demand competing with monetary demand for precious metals is instructive. In the 19th century, silver served as money throughout much of the world. The United States operated on a bimetallic standard. Silver coins circulated alongside gold. The monetary demand for silver was enormous, but silver also had industrial uses: photography, electronics, medicine. As industrial applications grew, tension emerged between monetary demand and industrial demand. The tension was resolved through demonetization. The crime of 1873, the Coinage Act that ended silver's monetary status in the United States, was not merely a policy choice. It was a resolution to an emerging conflict. Industrial interests required silver as an input. Monetary interests required silver as money. The same metal could not serve both functions indefinitely at a fixed monetary price. Demonetization freed silver for industrial use. The monetary price floor was removed. Silver became a commodity subject to supply and demand rather than fixed by law. For a century, this resolution held. Industrial users accessed silver without competing against monetary demand. Above-ground stockpiles grew as photography, electronics, and other industries consumed silver and then discarded it into landfills or recycling streams. The resolution is now failing. Industrial demand has exploded beyond any historical precedent. Solar panels alone consume over 140 million ounces annually, more than the entire photography industry consumed at its peak. Electric vehicles require silver for battery connections, motor contacts, and charging infrastructure. 5G networks require silver for antenna arrays and signal processing. Total industrial demand now exceeds 800 million ounces annually. Mining production is approximately 830 million ounces. The margin between production and industrial consumption alone has compressed to nearly nothing. But industrial demand is not the only demand. Investment demand, the modern expression of monetary demand, has reawakened. Coins, bars, and ETF holdings absorb over 200 million ounces annually. Total demand exceeds 1 billion ounces. Total supply is approximately 1 billion ounces when recycling is included. The market is balanced on a knife's edge. Any disruption, a mine closure, a refinery fire, a geopolitical shock, tips the balance into deficit. The production halts are not the disruption. The production halts are the consequence of a market that has been in structural deficit, drawing down remaining stockpiles for years. The specific dynamics of silver in electric vehicles deserve examination. An electric vehicle contains between 1 and 2 ounces of silver, depending on design. This seems small, perhaps $50 to $100 of silver in a vehicle costing $50,000. But the aggregate matters. Global electric vehicle production is projected to reach 40 million units annually by 2030. At 1.5 ounces per vehicle, this represents 60 million ounces of silver demand annually, demand that did not exist a decade ago. This demand is in addition to existing automotive silver use. Internal combustion vehicles also contain silver in electrical contacts, in sensors, and control systems. The automotive industry as a whole consumes over 50 million ounces annually. But the critical difference with electric vehicles is the inelasticity of demand. An internal combustion vehicle can be redesigned to reduce silver content. Alternative materials exist for many applications. The redesign takes time and investment, but it is possible. Electric vehicles have fewer alternatives. The electrical connections that carry high currents from battery to motor require the highest conductivity available. Silver provides that conductivity, copper is a distant second, aluminum is third. At the power levels electric vehicles require, substituting copper for silver means larger connections, more heat generation, reduced efficiency. The vehicle becomes heavier, the range decreases, the charging time increases. These trade-offs have economic value. A manufacturer will pay a premium for silver to avoid them, up to a point. The question is where that point lies. The production halts suggest the point has been reached or exceeded. The manufacturers could source silver at current prices, but the economics of production no longer work. Either the vehicle price must increase beyond what the market will bear, or production must pause until input costs decline. But input costs may not decline. The structural deficit does not resolve because manufacturers pause production. The deficit reflects supply constraints that persist regardless of demand fluctuations. This is the trap. Industrial users need silver. The silver does not exist in sufficient quantity. Pausing production does not create silver. It merely transfers the shortage from one point in the supply chain to another. The response of industrial users to commodity shortages typically follows a predictable pattern. First, users pay higher prices. They absorb the cost increase into their margins or pass it to consumers. Second, users secure supply through long-term contracts. They pay premiums for guaranteed delivery rather than rely on spot markets. Third, users stockpile. They accumulate inventory beyond immediate needs to ensure against future shortages. Fourth, users substitute. They redesign products to use alternative materials. Fifth, users relocate production. They move manufacturing to regions with better access to the scarce input. Each response has been observed in the current silver situation. Prices have risen substantially from levels that prevailed a decade ago. Long-term contracts have been signed at premiums above spot prices, contracts that guarantee delivery but at costs that exceed current market quotations. Stockpiling has accelerated. Reports indicate that major manufacturers have accumulated silver inventories representing months of production needs, inventory that is not available to other users. Substitution research has intensified. Billions have been invested in alternatives to silver for various applications. Some progress has been made in reducing silver content in solar cells, but fundamental substitution, replacing silver entirely, remains elusive for high conductivity applications. Production relocation has begun. Manufacturers have explored sourcing from regions with domestic silver production or refining capacity, but none of these responses has resolved the fundamental imbalance. The production halts indicate that the responses have been exhausted. Prices have risen beyond what economics can absorb. Contracts cannot guarantee delivery that does not exist. Stockpiles have been drawn down. Substitution has reached its limits for current technology. Relocation cannot access silver that is not being produced. What remains when all responses have been exhausted? Rationing. Allocation. The mechanisms that emerge when markets cannot clear through price alone. Silver's monetary history shapes how rationing unfolds differently than for purely industrial commodities. When copper is scarce, industrial users compete with each other. They bid up the price until the least efficient users exit. The market clears at a higher price with lower quantity. When silver is scarce, industrial users compete not only with each other, but with monetary demand. Monetary demand for silver is not price sensitive in the conventional sense. Someone acquiring silver as monetary insurance is not primarily concerned with the dollar price. They are concerned with acquiring the metal. The higher the price, the more urgent the acquisition appears. the signal of system stress that motivated the acquisition in the first place. This creates a dynamic that does not exist in purely industrial commodities. Rising prices do not reliably reduce monetary demand. Rising prices may increase monetary demand by confirming the thesis that motivated acquisition. Industrial users face a competitor that does not exit when prices rise. The competitor intensifies. This dynamic was visible in the 2010-2011 silver spike. Prices rose from $18 to nearly $50. Industrial demand showed price sensitivity. Some users reduced consumption. But investment demand accelerated. The higher prices attracted more buyers seeking monetary insurance, not fewer. The same dynamic appears to be operating now. Industrial users are pausing production, demonstrating price sensitivity, but investment demand shows no sign of abating. Coin and bar sales remain robust. ETF inflows continue. The monetary demand that competes with industrial demand is not exiting. The market cannot clear through price alone when one category of demand does not respond to price in the expected direction. Central banks do not hold silver as reserves. This absence shapes the current situation in ways that are underappreciated. Central banks hold gold, over 35,000 metric tons globally. This gold provides a buffer. If gold prices spike dramatically, central banks can theoretically sell reserves to calm markets. The inventory exists. No such buffer exists for silver. Government silver stockpiles were liquidated decades ago. The United States strategic silver stockpile is functionally depleted. Other governments hold negligible amounts. This means there is no lender of last resort for silver. No institution holds reserves that can be deployed to ease shortage. No policy mechanism exists to bridge the gap between supply and demand. The market must clear through price, through rationing, or through destruction of demand. There is no fourth option. There is no intervention available that can create silver that does not exist. This absence distinguishes silver from most commodities where government intervention, strategic reserve releases, export restrictions, import subsidies, can moderate price spikes. For silver, the market is on its own. Industrial users cannot appeal to government stockpiles. Investment buyers cannot be satisfied by reserve sales. The shortage is real, and there is no mechanism to paper over it. The implications extend beyond the automotive industry. Solar panel production depends on silver. The paste that forms the electrical contacts on photovoltaic cells requires silver's conductivity. Alternatives are being researched but remain years from commercial viability at scale. Medical device production depends on silver. Antimicrobial coatings, wound dressings, surgical instruments, applications where silver's properties are not merely useful, but irreplaceable. Electronics production depends on silver. Contacts, switches, connectors, solder, the components that make electrical systems function reliably in harsh conditions. Water purification depends on silver. Systems that use silver's antimicrobial properties to ensure safe drinking water in contexts where chemical treatment is impractical. Each of these industries faces the same constraints as automotive manufacturers. Each competes for the same limited supply. Each has limited substitution options. A shortage that halts automotive production does not remain confined to automotive production. The same supply constraints affect every silver-dependent industry simultaneously. This interconnection means that rationing, if it emerges, will not be isolated. It will ripple across industries, across geographies, across applications. The production halts in automotive are the most visible symptom because automotive production is highly visible. But the underlying condition affects everything that requires silver. There are beliefs about silver supply that circulate widely and deserve examination. The first belief is that mining production will increase to meet demand. Mining production responds to price, but slowly. A new silver mine takes 7 to 15 years from discovery to production. Permitting, financing, construction, commissioning. Each stage takes years. Price increases today do not produce new supply today. They produce new supply a decade from now if exploration discovers deposits, if permitting succeeds, if financing is arranged, if construction proceeds without delay. Meanwhile, existing mines are depleting. The average grade of silver ore has declined for decades. Miners must process more rock to extract the same amount of silver. Costs rise, production stagnates. The belief that supply will increase to meet demand assumes a responsiveness that does not exist in mining timelines. The second belief is that recycling will fill the gap. Silver is recyclable. Jewelry can be melted, industrial scrap can be recovered, electronic waste contains silver that can be extracted, but recycling is constrained by collection infrastructure, by processing capacity, by the economics of extraction from dispersed sources. Current recycling recovers approximately 150 million ounces annually. This rate has been relatively stable despite rising prices. The infrastructure to dramatically increase recycling does not exist and cannot be built quickly. The belief that recycling will fill the gap assumes capacity that would require years of investment to create. The third belief is that substitution will eliminate the shortage. Substitution is possible in some applications. Copper can replace silver where conductivity requirements are less stringent. Aluminum can replace silver in some contexts. Advanced materials may eventually match silver's properties. But substitution in critical applications, the applications where silver's unique properties are essential, remains distant. Solar cell efficiency depends on silver's conductivity. Electric vehicle performance depends on silver's properties. Medical applications depend on silver's antimicrobial effects. The belief that substitution will eliminate the shortage assumes technological breakthroughs that have not occurred and may not occur on relevant timelines. The production halts force a question that has been deferred for decades. What is silver? Is silver an industrial commodity, a useful input to manufacturing, priced according to supply and demand for industrial applications? Or is silver money, a monetary metal with 5,000 years of history, valued as a store of wealth beyond any industrial function? The answer cannot be both when supply is constrained. If silver is merely industrial, then price should rise until industrial demand is rationed to match supply. Investment demand, monetary demand, is a distortion to be discouraged. If silver is money, then industrial consumption of monetary metal is the distortion. Using money as an industrial input, consuming it rather than preserving it, depletes the monetary stock. For decades, the answer was implicit. Silver is industrial. Monetary demand was suppressed through various mechanisms. Industrial users accessed silver freely. The monetary function was dormant. The production halts suggest this answer is being contested. Monetary demand has reawakened. It competes with industrial demand. The competition cannot be resolved through price alone because monetary demand does not respond to price in conventional ways. The question of what silver is, commodity or money, is being asked again after a century of assumed answer. The resolution of that question will shape not only silver's price, but the structure of industries that depend on silver and the monetary system within which silver exists. This is not analysis that predicts where prices go. Prices will go where supply and demand, including monetary demand, dictate. No analysis can predict the resolution of forces this fundamental. What can be observed is the nature of the forces: industrial demand that cannot be easily reduced, supply that cannot quickly expand, monetary demand that does not respond to price in conventional ways, stockpiles that have been depleted over decades, no government reserves to deploy as buffer. These forces are structural. They do not resolve through normal market cycles. They persist until something fundamental changes. Either supply dramatically increases, or demand is destroyed, or a new equilibrium is established that looks nothing like the old equilibrium. The production halts are symptoms of this structural condition. They are not the story, they are evidence of the story. The story is that silver, a monetary metal pressed into industrial service, has reached the limits of a dual role. The metal cannot simultaneously serve as industrial input consumed in increasing quantities and monetary insurance held in increasing quantities. The competition between these functions is now visible. It will remain visible until it resolves. Gold does not rise, confidence falls, silver does not spike, systems strain. The production halts are not about electric vehicles. They are about a metal that cannot be two things at once when the quantity is finite and both demands are growing. Industrial civilization chose to consume its monetary inheritance. It converted silver from money to input, from store of value to industrial waste, dispersed across landfills and recycling streams. That choice had consequences deferred. The consequences are now arriving. Not as price movements to be traded, as structural shifts to be understood. The difference between a price and a signal matters. A price is a number. A signal is information. The production halts are information. They inform us that the arrangement, silver as industrial commodity, monetary function suppressed, supply assumed to be sufficient, that arrangement is ending. What replaces it cannot be predicted, but that it will be replaced is no longer speculation. It is observation. For those who distinguish between numbers and meaning, the meaning is clear, the numbers will follow.